push record. So I know it's recording. All right, so what questions do we have? I know it was kind of like a little bit different material. Is there any question from the notes that I can, because I posted the key for the notes on the Walker web. Is there, excuse me, is there any like part of the material that I can clarify at this point?
The last one just kind of confused me a bit.
On the notes?
Yeah.
Okay. I'm gonna share my screen here. Okay, so this one was kind of in this one right here, Sid.
Yeah.
This last one. Okay. So there's two, as you can see here, like this is the binomial theorem here, and you can use the binomial theorem. So this combination notation, n choose 0 and choose 1, this little parenthesis is just another way of writing that notation for a combination. So if you remember last time I showed you in your calculator how you can calculate the permutations and combinations, and this is just another way of doing that combination notation there. So you can use the binomial theorem to expand it, and you can also use Pascal's triangle. But in this last example, where you're finding just one term, this is a little formula here that you can use to find that one term, and then if you need to find just the coefficient. So let's walk through that for a second. So for this example, it says, find the coefficient for the term containing y to the 7th in the expansion of 5x minus 2y to the 9th without actually finding the entire expansion. So first off, think about which term y to the 7th would actually be, like which number in the process, and if you were to expand it, which term would it be? So if you think about it, the y is actually, so if you think about this is your a term and your b term, y to the 7th would actually be part of your b term over here in this little, in the parentheses. So if you think about it, the b terms actually, the a term exponents, they go down. So you start with 9, 8, 7, 6, blah, blah, blah. But the b term actually goes up. So you start with b to the 0, then b to the 1st, and then they actually go up by 1. So because y would actually be part of that b term, okay, you have to think about which term would it actually be. And you can count from either end of the expansion. But remember, the first term is always 0, which would be the first term, right? So 0, 1, 2, 3, 4, 5, 6, 7. So actually, y to the 7th would be the 8th term, okay? Because remember, in the first term, it's always, it would be parentheses negative 2y to the 0 power. You have to remember that's part of that. So this would actually be the 8th term. So if I'm trying to find the 8th term, so this is a formula here, rth term, so r is going to be 8, okay? That's what the r represents, is which term you're actually trying to find, okay? And then n represents the exponent would be 9 in this example, okay? So if we go down here, if I want to find the 8th term in this expansion, all right, remember this parentheses n over r minus 1 is just different notation for finding the combination. So I do 9, which is the exponent, and then r is 8. So 8 minus 1 would be 7. So this part right here would be 9, choose 7 for a combination. And then to find the terms here, I have parentheses 5x, because that would be this term. And then I do basically 9 minus r minus 1. So 9 minus 7 is 2. And then my second term is negative 2y. And you do r minus 1, so that would be 7. So remember, guys, your exponents here in the expansion should always add up to the original exponent here. So 9, 2 plus 7 is 9. It should always add up to that. And then from here, 9 choose 7, you can use your calculator. And it ends up being 36. And then you just simplify this. So 5x squared is 25x squared. And then negative 2y to the 7th is that. And then simplify down here. And then once you're done, all it was asking was for the coefficient. So I just circled negative 1015, 200. And that would be the coefficient. So on that worksheet, on that practice sheet, take some time and actually go in and practice doing that, because a lot of those questions deal with using just this little formula. That way you don't have to expand it. Expanding it using the binomial theorem and then finding the 8th term, it's going to take you a few minutes. Rather, you could actually just use this little formula to do it. Does that help, Sid? And it's going to take a little practice. It's very unfamiliar, I know. But like I said, using the binomial theorem this way, you see how long that took? It's a long process and there's a lot of room for error, okay? And there's going to be some times you're going to have to do that. It'll ask you in your homework. It did ask you to actually expand it, okay? All right. All right, so which homework questions could I do for you guys? And I posted the actual answer key. It just has the answer. It doesn't actually have the work done to it because I didn't want you guys to, I wanted you guys to take the time and do the actual work. But the answer key, if you pull that up from the Walker Web, you can see if your answers match that. And if you're really struggling, guys, like trying to do this worksheet and you need to see the worked out answer key, I don't mind sending it. So just reach out to me via email if you need to see the entire process, if that'll help you. Okay, I know they're not numbered on the worksheet, but which ones can I do to help you? Just say like first sheet, second sheet, all that kind of stuff. Anyone you'd like to see worked out? Drew?
Could you do the one on the bottom left on the first sheet?
Okay.
On the first page.
Okay. All right, so this one said find the 10th term. Is that right, Drew? In the expansion of,
Yeah.
Okay. So x plus y, that's supposed to be a 23. Pull up my sleeve. And then find the 10th term. Okay. So if it's asking for the 10th term, in that little formula that I showed you, let r is going to be 10. So that means r minus 1 would be 9. So if you remember the formula, it was n r minus 1, a n minus 1, and then b r minus 1. So n is actually going to be 23. That's our exponent. And this is actually your a term, and this is your b term. So now I'm just going to plug it in. So it would be parentheses 23, and then r minus 1 is 9. And then x, so 23 minus 9 gives you 14. And then y would be r minus 1, which is 9. Goes here. Okay. So from here, because our terms are kind of easy, x to the 14th, y to the 9th, the only thing you have to do is put that in your calculator. So this is the same thing as 23 combination, choose 9. And if you put that in your calculator, you should get 817,190. That's a comma. And then x to the 14th, y to the 9th. And that would be the entire term, the 10th term.
Okay, thank you.
You're
I
welcome.
have a question real quick.
Yeah.
So for the two equations to find like the certain term, are they just interchangeable, or do you have to use certain one?
Interchangeable. Yeah. So
Okay.
I think one is just more simplified than the other. I just use this one because I just remember 23 minus 9 gives me this. Yeah, they're both the same. One's just more simplified than the other. All right, what else from that worksheet can I help you guys with? And maybe you need more time, look at the answers or whatever. Let's see. Oops. All right, any ones I can work out for you guys? like I said, if you're working on it still, just make sure you send it to me by the end of the day, but I can send you the total worked out example, just so you can see the full process. But basically what I just did for Drew for that one is really the entire first sheet. The only difference is the first few, you actually have to figure out what term it is. And that's just basically kind of counting in your head to see which one it could be. And then I think on the second sheet, there were a few you actually had to expand. Okay, and you can use, like I said, you can use either Pascal's triangle. I like the binomial theorem. I think it's way faster. You don't have to really remember the whole pattern of the triangle, but I mean, you can use your notes, so you can obviously just see it.
Oh, I'm sorry. Can you go over one of the expand the binomial questions?
Okay, so let's do, you want to do one that had like a square root in it?
Yeah.
Okay, so let's do the, we'll do the last one on the second page. So go ahead and grab your calculator. It might be helpful. So the last one on the second page was the square root of x to the third power. So I use the binomial theorem, and because my exponent is 3, I start off my coefficient, this is supposed to be 3, choose 0, and this is my a term, and that's my b term. So then I do my a term starts off with the highest, and then my b term is always 0. And then plus 3, choose 1 would go next. Drop down 1, and then my b term goes up by 1. So as you can see, guys, look at the exponents here. 3 plus 0 is 3. 2 plus 1 is 3. And the last one. All right, so once I have this, okay, then I just use my calculator. You can do 3, choose 0 using your calculator, but 3, choose 0 is always going to be 1. And then I simplify each part. So the square root of x to the third power, you have to think about that's the square root of x times the square root of x times the square root of x. It's actually x square root of x, x. And anything to the 0 power is just 1. So that's good to go. All right, and then 3, choose 1. So you hit 3 in your calculator, math. Oops. And you get 3. And then the square root of x squared is just x. And then you have the square root of 2 to the first power, which is just the square root of 2. And guys, we're going to go back in and clean this up. So I'm just going to leave it like that for now. All right, and then 3, choose 2. Is 3 as well. Square root of x to the first power is just the square root of x. The square root of 2 squared is just 2. And then lastly, 3, choose 3. There's only one way to do that. The square root of x to the 0 is just 1. And then the square root of 2 to the third power, if I think about it that way, is 2 square roots of. And this is multiplying by 1. So now I'm going to clean it up. And then put those next to each other. 3 times 2 is 6. And then lastly, this is just 2 square roots of 2. And this would be your final answer here. So basically, you do that same process. Sometimes it's because you actually have like I think in one of them was like 3x minus 4y. So you have to actually raise numbers. So the coefficients can get a little bit big. But like I said, just take it step by step. Try not to do too much at once and be kind of organized when you do it. So just take it step by step. Write it all out first. Do your first part of your simplifying and then clean it up at the end.
Thank you.
Like I said, we could have done this one using Pascal's triangle too, to get like the 1, 3, 3, 1. That comes from Pascal's triangle, or you can do the binomial theorem, the 3, 2, 0, 3, 2. So either way that you like doing it, it's totally up to you. I kind of like the binomial theorem, but you can definitely use Pascal's triangle too. All right. All right, guys. Anything else I can answer? Like I said, if you're still working on it, just keep working on it. And if you're really struggling, send me an email. I can send you all the work that I did on my sheet, and that might be more helpful too. Okay. So just finish up that homework sheet today. And then the Google form I sent you is just like a 5-question little quiz for 9.1, the basic combinatorics. What's on that Google form? Not this section, it's just 9.1, okay? Okay, so just reach out to me. I have another call at 10:30, so I'll be here if you just need to like ask me a question via email or just send me a Zoom chat and we can talk for a few minutes, okay? Anything else I can help you with? All right, guys. Knock out that stuff, and then like I said, our next week is going to be should be kind of simple. I kind of broke our last section is 9.3, which is talking about arithmetic and geometric sequences, which you should have seen before. I broke it up into 2 sections because it is our last section. We can kind of take it at a slower pace, and then that's it. We're done, and we'll have a little test, and we'll be done. So one more week of new stuff, sort of, and then we're good to go. So in the home stretch, okay? Have a great weekend. Like I said, I'll be here if you need me, okay? Okay.
Thank you.
Bye.
Thank you.
Thank you.
Bye.